So we talked about the linked list implementation of queues. Queues. Since queue is also a list, it can be implemented using an array tool. An array implementation can also be beneficial because one can prevent the queue from growing very long. So how do we perform an array implementation of the queue? So I'm just going to give you a sketch of this queue here, or let me call it ADT queue, and some array of some element type. Okay. And we have the same interface functions. Create an empty queue. Check whether the queue is empty. On queue. DQ. And can also do a queue full because it's an array implementation. Okay. I might do, as we saw, the queue has 2 pointers, front and rear. Okay. So how do I store this in a queue? So initially I'll have an array with front and rear with an empty queue pointing to the same position. Then what do? I insert an element into the queue. Let's say I do an on queue. X, this is front now, and this is rear. Okay. Then I can keep on queuing like this. Let's say I have X, Y, Z, W, R. This is front, this is rear. Suppose I DQ now. What will happen? Front will suppose I DQ. What will happen? X will be removed and I'll have Y, and this will be front. Okay. And this will still point to rear. But you've already, now suppose I want to unqueue. It's already full. So what do? I need a mechanism. I want you to figure this out by which I can put something back here. Let's say I'm putting L. And now this will be the new rear. Okay. It'll be the new rear. Now, so I can keep doing this, and the idea of this is called a circular queue implemented using an array. I want you to think about it, how you will implement this. And the queue is found somewhere between front and rear over here. That's it. Okay. Now there's a problem with this implementation because now let's say I have this situation here and I am on queuing one more element. Then what will happen? let's say I'm adding M, then what will happen? Rear is already pointing here. There's one element still, and front will also point to this. And you can say the queue is full. But we saw a while ago that front and rear pointing to was also an empty queue. Okay. So I want you to figure out how you will solve this problem. How you will solve this. Okay. And there are other underlying representations for queues. There are some nice problems like this. It's called a circularly linked list problem. I gave a pointer P, only one single pointer, no front and rear. How can I devise? And by the way, all operations on queues using arrays are big O of 1. Similarly, this is a circularly linked list with one pointer, P, and I want you to devise all queue operations using order 1. Okay, so take this as a simple assignment to do, and we'll stop here on queues. Yeah, we can also perform or can also define a queue ADT, just like we did the stack using the list ADT. And let's see how we'll do this. So I can define an ADT queue, and it has as its private part list ADT L. And we could also store front and rear, which are of type position as before. And we can write interface functions of this kind. Right? On queue, I'm sorry, before on queue, let's create a list. Let's say make null. And what we could do here is we create the list and say L dot make null. And we could further say front is L dot first, position of the first element, and last is, or rear is L dot end. I can write a make null like this. Then what will on queue be? Where we try to insert next element of some element type. Clearly the rear is pointing to the end. So we'll do L dot inserter L dot, sorry, insert of L dot X comma N dot L dot. Remember, this is how we had the format of the list, X comma L dot end. Okay, and DQ will be to return the element. We'll say return, which is of element type, say L dot retrieve of L dot first are first. I could just do this. Sorry. First here. First front. Sorry. Front. Here too I can write rear because I'm making two pointers over here. And I can say L dot deleter front. Okay. And front will of course have to be updated. L dot first. Okay. This can be the BQ operation, and empty would be L dot first equals L dot end return true. Okay, and so on. So you can keep writing all the front would be what out of Q of L dot retrieve of L dot first, no deletion, just like we did for the top and the for stack top. Look at what is stack top and removing the element which is there on top, stack top. So this is what we have seen so far of ADTs called this stacks. Sorry, we started with basic arrays. These are the fundamental abstract data types that we have. Lists, stacks, queues, and we saw that each one of them is a special ADT in that specific operations are permitted. All these belong to that of the linear ADTs. Okay. We'll talk about other types of ADTs in the